parallel beam of monochromatic light of wavelength lambda passes through a rectangular slit of width b. Wavelength is known. Rectangular slit of passes through a rectangle. It is a singular slit diffraction. Rectangular slit of width b is known, and is incident on the screen at distance x from the slit. What is the width of the central maxima of the diffraction pattern? So the width of the central maxima, so you get something like this. This is your slit over here. This width is also given by b. This distance is given by x over here, and this is the screen, and you observe. Okay, so you observe something like this. This is what is being. What is that you are getting over? Okay, he is asking you what is this value. This value is called as beta, which should now be equal to 2 times lambda capital D divided by small d. Okay. So now let us map the parameters correspondingly. So 2 times lambda into what is capital D here? Distance between the slit and the screen. Here it is given as x. I'll write x over here. And what is D here? The single slit width diffraction, which is B here, divided by B over here. So it is 2 lambda x by B. Where is this distance? 2 lambda x by B, and this D over here. Width of the central maxima. See, most of the time we only ask you about angular width. If it is angular width, full angular width, then this should be 2 lambda divided by B. It is half angular width, then it should be lambda by B. Okay, this is of nothing of use. Okay, the lambda x by B is of no use. So this is the right answer. So B D is the right answer.